Hello, today we will talk about conservation of energy. First of all, let's remember what the definition of energy was. Energy is the capability of doing work. For instance, what the definition of work then? Let's remember by starting the definition of the work. If any force is applied on an object, making an angle of theta with the positive x-axis, then the component of the F force parallel to the x-axis would be equal to F times cosine theta. By the effect of the force on the object, the position of the object will change from subscript 1 to the subscript 2. Here, the magnitude of the displacement vector would be equal to delta x. Then, the work done by the force on the object would be equal to F times cosine theta times delta x. The work done by the force on the object will be stored as an energy on the object, and the energy in this case would be equal to the kinetic energy. But we say that energy could neither be destroyed nor created from zero. So the energy will be conserved and also transferred from part to part, like potential energy. Let's write it, potential energy and kinetic energy. Here, in the further classes, we will see that the potential energy also will be grouped in itself, like elastic potential energy and gravitational potential energy. Let's look at the example we see on the figure. Here, the athlete changes its body position from the 1 subscript to the 2 subscript. During the process, the energy of the athlete, the kinetic energy of the athlete, will be transformed to the first potential energy of itself and also the elastic potential energy of the bent rope itself. So we see that the energy is conserved during the process. Now let's look at the forces which cause the energy transformation on the objects and on the systems. We say that conservative and non-conservative forces as the grouped, and the conservative force will be defined as the work done by the force on an object moving from one point to another. Depends only on the initial and final positions of the object and is independent of the particular path taken. If the work done by the force does not depend on the path itself, but depends only on the initial and final positions of the object, then we will say that the force will be conservative. But if the work done by the force does depend on the path itself and not only the initial and final positions but also the path itself, then we will say that the force is non-conservative. Now let's give an example for conservative and non-conservative forces. We can say that generally the field forces are conservative, like gravitational force and electric and magnetic forces could be given as an example for conservative forces. And for non-conservative forces, we see generally that the forces which need contact with the force applied surface and also the object requires contact, then we can say that these type of forces will be defined as non-conservative forces, like friction, skin friction or friction forces, and also the tension force which exists on the rope on the objects. So we can say that conservative forces and non-conservative forces could be grouped into by this definition. And we should remember that the work done by the conservative forces depends only on the initial and final positions of the path which is applied on the object, but for non-conservative forces, the path seen will be determined into the magnitude of the work done by the non-conservative forces. Okay, then we can say that this type of energies are transformed within each other like potential and kinetic energy, and this could be entered in detail in the further lessons. Thank you for listening.